Assumptions for two non-parametric statistical tests. Non-parametric statistical tests are used when the data are not parametric, i.e. not normally distributed. The first statistical test is the Kruskal-Wallis test, is used when the data are sorted in unrelated groups. The second statistical test is Friedman's test, which is a test used when the data are sorted into related groups, and both tests are also used when there are three or more groups. Assumptions for Kruskal-Wallis test, or alternatively can be called the H test, which is a non-parametric test. The test is an equivalent of one-way ANOVA statistical test that will determine whether there is a difference between multiple groups, three or more groups. The H test can be also called one-way ANOVA on ranks, and it is a rank-based non-parametric statistical test. The test will determine whether there are statistical significant differences between the distribution of three or more independent groups. So to use this test, the data have to be sorted into three or more separate, unrelated, independent groups. The test will also compare the medians for each group. Since it is a non-parametric, then the mean will be used for comparison. The test is an extension of a Mann-Whitney U test. The Mann-Whitney U test is a statistical test that is non-parametric. However, it is only used when there are only two groups, not more than two groups. More than two groups, three groups or more, then the Kruskal-Wallis test is the one to use. This is a test that can be used when normality assumption is violated. When the one-way ANOVA can't be used because the data is not normally distributed, then the Kruskal-Wallis test is an alternative test when the data are non-parametric. The H test can't determine which specific group or groups of independent variable are statistically significantly different from each other. So it can't tell which two or three or four or more groups that are different. It will only determine whether there is a significant difference between multiple groups, but without specifying which groups are different. So it can determine that at least two groups were different using post-hoc test. To determine which groups or two groups are statistically different, then the post-hoc test can be used. The H test does not assume normality in the data, so it is suitable for the data that are non-parametric. The test, which is Kruskal-Wallis test, is less sensitive to outlier than the one-way ANOVA. Outliers are an extreme low or high values that deviate from the other scores in the data set. The H test is used for non-parametric test. It doesn't require normal distribution of the data. The data can be ordinal or continuous. Ordinal data is categorical data with order in it, such as a Likert scale, which is used in surveys and questionnaire. Continuous data that has numerical scale in it, but is not normally distributed in this case. So the H-test can be performed in a data that are ordinal or continuous. The test can be performed when there are multiple groups and it compare these groups that are unpaired, unmatched, independent of each others. So to perform the Kruskal-Wallis test, null hypothesis has to be generated, and that null hypothesis will state that all groups have the same distribution, which means that the medians across all groups are equals. The alternative hypothesis will state that at least one group differs. So there is a difference between those multiple groups. So if the p-value is less than 0.05, then reject the null hypothesis. So what are assumptions? Assumptions are certain conditions or criteria or features or characteristic of the data or about the data that must be met before performing any statistical test to generate valid and reliable results. Every statistical test have a set of assumptions or conditions that have to be satisfied or met. Violation of those assumptions can lead to unreliable findings, which eventually will lead to incorrect conclusions. Assumptions for Kruskal-Wallis test in brief are: groups are independent, observations are independent, dependent variable is ordinal or continuous, independent variable consists of at least two levels, two or more, and samples are independent and random, and the distribution in each group have similar shapes. So there are 5 major assumptions that have to be fulfilled or met before performing Kruskal-Wallis test on a data. The first assumption is that the dependent variable can be ordinal or continuous. Dependent variable can be measured on an ordinal scale or at a continuous scale that is not nominal but it is numerical and it is not normally distributed. The continuous scale can be interval or ratio. The second assumption is that independent of observations, which means that there is no relationship between observation within each group or between groups. So data within each group are independent of one another, and groups are independent, not overlapping, not related, and different participant in each group. That is the meaning for independent observations. Each participant belongs to one group. Violation of this assumption, then use an alternative test, which is Friedman test. The third assumption for Kruskal-Wallis test is independent groups. So the independent variable should consist of 3 or more categorical, unmatched, unpaired, independent groups. Example is the profession, in which the data can be sorted into groups such as doctor, dentists, scientists, pharmacists, and so on. Ethnicity, in which there are white people, black people, Asian, and others. Groups are independent of one another. There should be no overlap or paired relationship between those groups, so they are unpaired groups. So Kruskal-Wallis test can be used for just 2 groups, However, the best choice for two groups is Mann-Whitney U test, which is an unparametric test that can be used when there are two groups. The fourth assumption is that there should be similar shapes of distributions. The test assumes that the distribution of the groups have a similar shape, similar spread, similar skewness, as the data are not normally distributed. So if the distributions have the same shape, perform Kruskal-Wallis test to compare the medians of groups. Violation of the shape assumption, then use an alternative test, which is Fligner-Killeen test, and use post-hoc test. The fifth assumptions that have to be met for performing the test is sufficient sample size. So each group should ideally have sufficient sample size to allow for accurate ranking of the data. Each group should have at least 5 observations to ensure reliable results. If some assumptions are violated, then use bootstrapping. Assumptions for Friedman rank sum test, which is a non-parametric test that is used when the data are non-parametric, i.e. the data are not normally distributed. And the test is used also when the data are repeated measures, which means that the data are paired or match groups or dependent groups. So the Friedman test is a non-parametric test that is used for data that are not normally distributed. This is an alternative to the repeated measure ANOVA, which is used when there are matched or paired groups or dependent groups, and when the data are normally distributed. The Friedman's test can be used when the data lacks normality, and the test of repeated measure ANOVA can't be used. The test also detects the differences between matched or related or dependent groups. So the groups have to be related, which means the same participant participate in each group. The test is based on using the median, and it ranks the data before performing the test. So it takes the data and put them into ranks and then perform the analysis on the data. An example of a repeated measure that can be used for the Friedman test is when we want to compare the efficacy of 3 different teaching methods on student performance, whether any of the 3 different teaching styles can enhance the student performance. Then the 3 different styles are the 3 different groups, but these groups are not different, they are related, as the same participant participate in each group, and the teaching style for each group is given a label. A second example is assessing the satisfaction of a group of people for 3 different surfaces. In this example, the participant participates in 3 different services, but those groups are related because the same participate in each group, but with different surfaces, to find out how satisfied is those people from these services, and which services differ from the other. This example can be used when the data are ordinal. And another example for the repeated measure data is analysis of repeated measures in medical experiment. It is very often that a drug want to be tested, and volunteers or participants are assigned to 3 or more groups, but these groups are related because the same participant participate in these groups, and testing whether the dose or the time of the dose can improve the efficacy of the drug. So there are multiple examples in a situation where this test can be used when the data are repeated measures, when the same participant exists in each group, but with different conditions tested for each group. To perform the Friedman's test, alternative and null hypothesis has to be generated and stated. The null hypothesis will state that the distributions of the groups are identical, which means the median ranks of groups or conditions are the same. The alternative hypothesis will state that at least one group differs in distribution, at least one group has different median ranks from the other. And then a p-value is calculated. If it is less than 0.05, then reject the null hypothesis and accept the alternative hypothesis, which indicates that there is a difference between the groups. So the things with the Friedman test is that it will try to determine if there is an overall difference or differences between the groups, for all the groups, without specifying which group is different from the other. So a post-hoc has to be done if the p-value is significant. The post-hoc test will assess pairwise group to find out the groups that differ. Assumptions. So this drags us to the main topic of this presentation, which is assumptions. Assumptions are specific conditions or criteria or characteristics of that data that have to be met before performing any statistical test to produce a reliable results. So each statistical test have a set of assumptions that have to be met or fulfilled. Violations of these assumptions can lead to incorrect findings and can lead to unreliable, incorrect conclusions. Some of the assumptions that are important for the Friedman test is that the independent variable has at least 3 levels in it, or 3 groups. The data come from related groups or matched samples, i.e. it is repeated measures from the same subject, the same participant participate in the groups. The samples are randomly selected from population, and the dependent variable can be ordinal or can be continuous. An ordinal variable is a variable is categorical, but there is an order in the category, such as the 5 Likert scales that is commonly used for surveys and questionnaires. Or the data can be numerical scale, continuous, but lacks normality. So the sample should not need to be normally distributed. So this test is designed for data that are not normally distributed. There are 8 assumptions that have to be met before performing the Friedman test. The first assumption is that paired related groups, which means that the test is for repeated measures data. Data have to be from the same subject under different conditions. This subject has been subjected to different conditions or criteria. Or those individuals are in a groups, but these individuals have matched or paired samples. Each participant participate in each group. The second assumption is that the data are ordinal or continuous. The dependent variable should be measured at either an ordinal rank data or at a continuous numerical scale, and that can be interval or ratio. And if it is a continuous data, then this data should be non-parametrics, which means lacks normality, to use this test. The third assumption is that there should be at least 3 groups. So the independent variable should consist of 3 or more related or matched groups, i.e. repeated measurements, which means that the samples are matched. The fourth assumption is the independence within groups, which means that the observation within each group should be independent of each other. No influence or overlap between the measurement in different groups. The fifth assumption is that comparable measurement scales, which means that the dependent variable measured on the same scales across all groups. The sixth assumption is rankable data. The data can be ranked, which means that order does exist in the observations. The seventh assumption is that there is no distribution assumption, which means that the test doesn't require that the dependent variable have to follow specific distribution. So this test is robust for violation of normality, and it is used when the data are not normally distributed. And the eighth assumption is sample size, as the sample should be sufficiently large to perform this test. So what to do when the violation of the assumptions is being detected or observed? Then use non-parametric methods such as Wilcoxon Signed-Rank Test for 2 paired groups. This test is used for 2 groups, and these groups are related. Friedman's is used for paired groups, but for 3 or more groups, or alternatively use the Kruskal-Wallis test when the groups are independent. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovi, RStatistic or Statistics, GraphPad, Prism, GPower, Python, and Mann. If you are a student or a researcher and you have a data, whether it is quantitative all qualitative and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovi, RStatistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.